Here is another question on linear momentum. Just one question. This question talks about a car with a mass of 980 kilogram initially traveling to the east. So that is this one, initially traveling to the east with a speed VC 19.6 meter per second and a 1500 kilogram pickup, which is this one, traveling north towards the same intersection. And unfortunately they collide and stick together and move off with a common velocity VF at 45 degrees to the x-axis, 45 degrees to the x-axis. And you got to find the initial speed of the truck, which is Vt. You have to find that, and you also have to find the final speed with which both of them go. Now in this case, you will have to look at the conservation of momentum first along the x-axis and then along the y-axis. Okay, what is the initial momentum along the x-axis? We know that this is the one that's moving along the x-axis. Therefore, so along the x-axis it is the car that's moving, and its initial momentum is its mass times velocity. But the final momentum is the mass of both of them together, because they are sticking together, times the final velocity and the cos component, because when you take this and take the cos component, that is what is going to be along the x-axis. So along the x-axis we have the initial momentum. Only this is moving along the x-axis, so it's mc times vc, and then both of them are sticking together, so both the masses are added up, times the final velocity and then cos theta, because that's what is going to give you along the x-axis. Similarly, along the y-axis, initially it's only the truck that's moving along the y-axis, so it's the product of its mass and velocity, and then final is the total mass times Vf and the sine of the component. Okay, so it's going to be sine theta. Now once you get these two equations using the conservation of momentum, divide 2 by 1, because you can see that on the right hand side these two quantities are going to get cancelled out. So is the final velocity, and you will have sine theta over cos theta, which is tan theta. That's on the right side. On the left side you have to write all this, which I've done. On the right side is tan theta. Now we can find the initial speed of the truck just by rearranging, because all the other quantities are given. The mass of the car is 980 kilograms. Its velocity is 19.6 times tan 45 degrees divided by the mass of the truck, which is 1500 kilograms, which gives 12.8 meter per second. Now substitute into this equation 1 and make Vf the subject. That means you got to take all this to the other side. It will go to the denominator. So you have mcvc divided by mc plus mt times cos theta. mc is 980 kilograms, vc is 19.6 divided by the sum of the masses times cos of the angle, cos 45. On solving this, you get 11.9 meter per second. And see, this is an important question because here you had to resolve the momentum along the x and the y axis. And you had to apply the conservation of momentum and get two individual equations and divide those and calculate whatever you need to find out. All right? Good luck. I hope you've understood it. Thank you.